Hi everyone, welcome to Feynman Education lecture on Binomial Theorem. So starting by definition, Binomial Theorem gives a method for expanding a two-term expression. So let's take a two-term expression a plus b to the power n. So Binomial Theorem says the expansion of this expression will be nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus ncr a to the power n minus r b to the power r, and then the last term will be b to the power n. Here you can see a trend happening. nc0 is changing from 0 to ncn, because in the last term here it is ncn, which has a value 1. Now what is happening to a? A is changing from a to the power n to a to the power n minus n, which is a to the power 0, which also gives us a value 1. And what is happening to b? B is changing from 0 to b to the power n. This is the reason the last term we only have b to the power n, because both these terms will have a value 1 in the last term. So now you have an idea of how to write a sequence of a plus b to the power n. It starts with nc0 a to the power n, b to the power 0, and it ends with b to the power n. Now a general equation for any term in a binomial expansion is this. So now let's see what is NCR indicates. As you learned in permutation and combination chapter, NCR is expanded as n factorial over r factorial times n minus r factorial. Okay, in some books the representations can be nr or cnr. All these indicates the same, which is combination. Now let's see the general term equation for general term. Now let's see equation for general term. So t r plus 1 will be written as ncr a to the power r n minus a to the power n minus r b to the power r. So in general, we can say that a plus b to the power n can be written as summation of k equals 0 to n nck a to the power n minus k b to the power k. Now let's take some special cases. What if, let's take a as x and b as minus y. So here we have a negative term in the expansion, which is x minus y, expansion of x minus y to the power n. How are we going to deal with these? So it will be x plus minus y to the power n. So our expansion will be nc0 x to the power n plus nc1 x to the power n minus 1 minus y plus nc2 x to the power n minus 2 minus y square, and it goes on till ncn minus y to the power n. Now let's take a as 1 and b as x. So here the equation for the expansion will be 1 plus x to the power n. That will be nc0 1 to the power n plus nc1 1 to the power n minus 1x till ncn x to the power n. So in short, we can write it as nc0 plus nc1x plus nc2x square up to ncn x to the power n. So these are some simpler methods you can use while expanding these. Now let's do a simple problem regarding binomial theorem in our part 1, which is expand x square plus 3 over x to the power 4 where x is not equal to 0. So using binomial theorem, the expansion for x square plus 3 over x to the power 4 can be written as 4c0 x square to the power 4 plus 4c1 x square to the power 3 over x plus 4c2 x square whole square 3 over x square plus 4c3 x square 3 over x whole cube plus 4c4 3 over x to the power 4. When you do the expansion, your answer will be x to the power 8 plus 4x to the power 6 times 3 over x plus 6 times x to the power 4 times 9 over x square plus 4 times x square times 27 over x cube plus 81 over x to the power 4. You can make it a little bit more shorter, which is x to the power 8 plus 12x to the power 5 plus 54x square plus 108 over x plus 81 over x to the power 4. In the next part, we will see some other different examples related to this topic. For lecture materials and information on mastering classes, please visit feynmandeducation.com. See you in the next part. Thank you.